Good morning, good afternoon, good evening. Welcome back to Chapter 8. We're talking about cell division. We just finished talking about mitosis. What tells a cell it's time to divide? Obviously, cells can't just reproduce constantly. That's called cancer, and we'll talk about that in a bit. What tells a cell it's time to divide? Well, the first thing are what we call growth factors. Growth factors is a special class of hormones. Remember that hormones are chemical messengers inside of, well, really almost every multicellular organism. Hormones are chemical messengers. Growth factors are a special category of hormones that their job specifically is to tell a cell to divide. And there are lots of different growth factors because there are lots of different cells. You don't want to have one message that tells all the cells to divide when you only need certain ones to divide. So there are lots of different growth factors. These are chemicals that stimulate division. Growth factors will tell a cell to divide, but cells have certain breaks in place, and these breaks, the whole job is to prevent a cell from dividing when it's not appropriate. Why wouldn't it be appropriate for a cell to divide? Well, a really good reason why a cell shouldn't divide is if it's not necessary. You should divide if there's been damage. You should divide if you're replacing a dead cell. But if there's nothing to replace, if there's no reason for you to divide, then you shouldn't divide. And so cells have what we call inhibitors. And the first inhibitor is called density-dependent inhibition. And that is, if a cell is surrounded on all sides by other cells, it's not supposed to divide. Just imagine like a brick wall. If there's a missing brick in the wall, then it's okay to make a new brick and to put in the missing spot. But if there's no missing brick, if all the bricks in the wall are intact, there's no reason to add extra bricks to the wall. You're just going to start making a mess. All right? And that's the same thing that goes for you inside your cell. If a cell is surrounded on all sides by other cells, it's not supposed to divide. Again, this is to prevent cancer. Cells also have what we call anchorage dependence. And that is that the only time a cell should divide is if it is attached to a surface. If it's not attached to a surface, it is not supposed to divide. And as a matter of fact, if any cell that is supposed to be attached to a surface finds that it isn't attached, it's actually supposed to kill itself. It is supposed to destroy itself. And that process is called apoptosis, just like it sounds. Apoptosis. Apoptosis is when a cell literally kills itself to prevent it from getting stuck somewhere it shouldn't and to prevent it from turning cancerous. Here we see anchorage dependence. If cells are attached to a surface, they're supposed to divide. If they're just floating free, they're not supposed to divide. Now that I've got cells that are surrounded by other cells on all sides, these cells are not supposed to divide. But if I remove some, well, now I can replace the ones that are gone. And so the cells on either side will divide and replace the cells that were removed. This is called density-dependent inhibition. If a cell breaks density-dependent inhibition, it just keeps dividing and dividing and dividing. We call that a tumor. What causes cells to become cancerous? That is not an easy question to answer. If it were, cancer would be easy to cure. The second problem is that cancer is not just one disease. Cancer is a lot of diseases. There are a lot of cancers that have a lot of different causes, and there's not one perfect cure-all, fix-all for cancer because it's not just one disease. There's a lot of cancers, and each one will respond to different treatments. What causes cancer? What causes cancer is that all of those breaks that are in place that are supposed to stop a cell from dividing, damage has happened at some point to those cells, and those breaks were broken. Just like if somebody cuts a brake line in your car, you can't stop your car anymore. If the genes that are responsible for preventing uncontrolled division are destroyed, then there's nothing preventing uncontrolled division. There are lots of these breaks. We talked about two of them. there are lots of these breaks, about a half a dozen or so, that are in place. And again, to become cancerous, they all have to be broken. And we all know someone, we've all probably are related to someone who either had or died of cancer. So, well, how is it then if it's a really rare event because there's all these breaks that are supposed to prevent it, then how does it happen? Okay, well, the first problem is, how many cells are you? And we said this before, you are 37 trillion cells. That's a lot of cells. There's got to be some bad ones in there. That's the first problem. The second problem is, most of the time, what is the age of the person that gets cancer? And the answer is, most of the time it's an older person, somewhere north of 40, but most of the time north of about 60. Right? Older people. They've had a long time for those 37 trillion cells, for some of them to get damaged in such a way that they start reproducing uncontrollably. There's this explanation that's referred to as the cumulative assault theory. Every day you're alive, the world's trying to kill you. If you've only been alive for 20 years, you've had 20 years of the world trying to kill you. If you've been alive for 70 years, you've had 70 years of the world trying to kill you. And so anybody that gets attacked for a long time, at some point the defenses are going to fail. And this is often what happens with cancer. Who usually gets it? It's usually elderly people. It's not always elderly, but it's usually elderly people that get it. Cancer cells are cells that have escaped the cell cycle. They're no longer being controlled by those breaks that we talked about. And so then they're just reproducing like mad. It's basically like that cell cycle. Imagine it's a clock, and now it's on fast forward. Instead of it taking 24 hours, now it's flipping over every hour, all right, just on fast forward. And that's what a cancer cell is like. It's going through the cell cycle on fast forward. They divide excessively and eventually will invade other tissues of the body. A tumor is a mass of cells that's growing where they shouldn't. A tumor is not necessarily cancerous, because a tumor can be one of two things. It can either be benign or malignant. Benign means it's not spreading, and if it isn't spreading, then you remove the tumor and it's taken care of and you're good. Malignant means that it is spreading, and if it is spreading, if this tumor has gone beyond the original confines of its home, if it's starting to spread into nearby tissues, then we say it's malignant, and then we say that person actually has cancer. Here is a tumor that has not invaded other tissue yet. Because it has not yet invaded other tissue, you remove this tumor and you don't have a problem. All right, the issue is solved and it is gone. If the tumor is allowed to progress, it can start to invade more tissue. Even at this stage, the tumor can be removed, but what do you have to do? You have to remove a lot more tissue than just a lump. You've got to remove a lot more tissue to get all of the cancerous cells, because you can't leave any of them behind. If you leave any of them behind, they are all clocks on fast forward. They're all zipping through the cell cycle too fast. If you leave any of them behind, then they'll just reform the tumor eventually. If you've gotten to the point to where it has broken and is now spreading, it has metastasized, well, now what that means is those cancerous cells are now spreading. They've broken that anchorage dependence, and they're just going to go and drift off into the circulatory system, and they'll get stuck somewhere else. And when they get stuck somewhere else, we'll just start reproducing wherever it is that they are. If you've gotten to this stage, this is referred to as stage 4 cancer. This is the stage where you've only got a few months or maybe a couple of years to live. There are lots of medicines you can take that can slow it down, but currently there's nothing that can stop it. Cancer.